Well, something went bang then. And all the lights have gone out in my house. Better go and sort that out. Oops. So we did a safety test there, but I think what actually happened is I had the range switch set to obviously the wrong setting, so it wasn't even switching the transformer on. But when I actually did turn the selector switch to the right thing, it powered up the transformer, and then something actually took a Burton. So again, that safety test that I did with the pat tester before, it was totally invalid. Wasn't the correct way to do it, but we live and learn, don't we? Now, it was actually this circuit board that exploded. I suspect though, given that it's only a very simple circuit board, that that isn't the problem. I would have thought that we've probably got an internal short circuit on this transformer, and that's actually what's why it's gone for a Burton. But let's have a look. Everything's unplugged now, so let's go ahead and just take that circuit board off and see what we can see. Now, given how rusty all this is, it's probably been stored in a damp barn or, you know, something like that. And that's the last thing that really you want to have, you know, electronics in. You don't want to have stuff getting damp or wet, especially things like transformers, because the insulation just fails on the primer. Okay, before we go ahead and we disconnect all these, it's probably worth me seeing if there's any marks on anything. Now, I can't see any markings on this circuit board, so we'll just have to make a note of what everything does. So we've got a white wire here going to the transformer, white, then we miss one, then we've got the red wires which go up to the remote switch on the front panel, so red, red. Then we've got brown and blue, which I'm guessing is our incoming supply. BRN and blue. So it just goes to show really, doesn't it, when you're being a bit cack-handed and not paying attention or not doing the job quite as you should, that's when it comes back and bites you. Oh, well, that terminal's just pulled out. So I don't know if you can see that, but the spade connector has pulled out with the actual connector itself, so that's no good, and the ends of it are burnt, so it's been arcing inside there. Oh, well and truly stuck. Keep that for later. I wonder if the others are going to be equally stuck. Right, okay, here's the circuit board, let's go ahead and undo it. Oh. Actually, I knew that socket wasn't going to fit, I just thought I'd take it out and show it a nut, because I haven't used it in ages and it's probably getting a bit lonely. Right, maybe that one. Is that turning or is it just spinning? No, it is actually coming undone. Kind of makes me think this is obviously why it's for sale at a farm sale like this. It was obviously totally knackered, and I suspect somebody just thought, well, probably easier to go and take it to this farm sale than it was take it to the tip. So here's the circuit board that we've taken out, and you can see that one of the connections there has been arcing out, and it's all burnt around it, and that's one of the spade connectors that fell out. And then the other spade connector here, well, I can't really see that it's burnt, but I can see the classic symbols like a little volcano. This has obviously been a dry joint at some time in the past, and that's just given way. So I don't know whether or not this connection here has failed because it was overcurrent, because the transformer's got a short on it, or it could have failed just because it was a, you know, a bad connection and there's a lot of current going through it. Sometimes connections do fail with expansion, the solder cracks, etc. So I don't know if this PCB is going to be worth repairing. I mean, it should be fairly easy to repair, but the question will be, is the transformer any good? Has the transformer got a short circuit on it? So before we spend too much time trying to repair this board, I think we need to go ahead and diagnose this transformer. I've just noticed there's a little link here, and it says on the board, if you look at the back of the board there, it's got a little 220 or 240 volt setting, so you can obviously change the tappings on this little transformer depending on maybe what your supply voltage is. I wonder if 220 is like European and 240 was British. I'm not exactly sure, but yeah, there it is anyway. Well, you know what, I'm going to go ahead and do what I actually should have done in the first place, which was disconnect the transformer and just measure it out separately. I should have known that a transformer looking as bad as this needed testing, and I should have also known that possibly that with all the switching involved in the primary circuit for this transformer, it was very unlikely that insulation test that I was going to do would have been a good test, because it was quite likely that I would have had this selector switch at the front set in the wrong position, so of course it wasn't actually seeing the transformer, which is where we think there could be a fault. So I'm going to go ahead and I'm going to measure this out separately. Okay, we've got this set to 500 volts, so I'm going to go off that's the live supply that gets switched into the transformer. I'm going to go on there, and we're going to go off the transformer case there, and let's press the test button. And surprisingly, that's a better reading than I was expecting. We're getting 200 meg, so that's clear. So it kind of comes back to, why did that circuit board just go up in smoke? Maybe it was just a bad connection, so I guess that means we've got to go ahead and resolder that circuit board. But I think when we power this thing up, we're going to have to be a lot more careful, if nothing else, because I don't really like keep tripping the main supply out in the house. So let's go ahead and repair that circuit board. But I've just noticed there is some things on this circuit board that are a little bit how you doing. So you can actually see that these two double terminals here, these are the switching contacts of the relay. So this is a normally open relay, and those are the switching contacts. So it switches the current between, well, I was going to say it switches it between these two contacts here. But this is a contact that wasn't connected, so you think, well, how does that work? Because there's no live connection. You'd think that the power would go up there and then down the other side when it's turned on. You can see that there's a little pin coming through there, and there's another pin. So if you look on the underside of the board here, and I don't have a way to get you in, can you see it just flashing down there somewhere? They've actually put a wire link between one of the legs on the transformer and what would be the live feed to the live feed to one side of the relay. And you just kind of think, well, why on earth would you do that? I mean, it also means that this transformer can't actually sit down because it's sat onto a wire link. So this wire link is connected between this terminal, which was actually the live terminal coming into the welder, and it goes across there. So that becomes the I don't know, the live supply to what you might call the common side of the relay, and then this is the switch side here, so it connects between there and there when the relay closes. You'd think the correct thing to do was to put the main supply, well, the power supply, into this one, and then it would have switched between that terminal and that one, but they decided to do that, or they decided not to do that for some unknown reason, and they decided to put a little bodge link in there. Well, you know, it's been a long time since you guys have been in my electronics workshop, so come inside with me while we solder these two terminals back in. So, you know, I think my weapons of choice today are going to be solder braid and probably an awful lot of flux. Right, these things are still looking pretty dirty, so we've got to go ahead and try and clean them up. I think I've got some steel brushes in here. So a steel one. I think that might be a steel one, or is that one brass? That one's brass, that one's steel. So we're going to go ahead and we're going to give these a good scrub with this steel brush. Basically all you do to retin them is keep running fresh solder onto them until they actually start taking the solder. And this flux that I'm using here is quite a strong aggressive flux that I use for things that are really dirty. I still think the chances of resurrecting this thing are slim, but seeing as we're here, we may as well just give it a coat of conformal coating, some dope, because you never know, it might come back to life, and it's easier to do it now than go back, take the board out, do it later. So here's a control board that I've just gone ahead and repaired that. So what we'll do is we'll reinstall that now. I think I might just put a couple of screws in because I think all this will be coming out again to clean everything up a bit better. Don't think you'll be able to see it, we've got our relay coming in now. So I think I'll just plug our transformer in. I'm going to plug it in and I'm going to go for broke. See if it's going to work or all my lights are going to go out again. Okay, so we've got a dim glow there, but nothing's gone bang. We've got a mains indicator on. Not sure what's going on there. I'll turn that off. I'm going to reinstall our link where our timer was. Well, I've gone ahead and I've plugged in our lamp limiter, and yeah, we are getting a bit of action. I think that relay is just clicking because the lamp limiter is knocking the voltage down a little bit. But having played with this selector switch, it doesn't really seem to be working properly. But I think all it actually is some bad connections, because at the moment there's no power on the transformer. But if I just kind of fiddle with that, can you see that occasionally? He said occasionally. There we go. It did come on. I was going to say we've got a bad switch, but I wonder if we've got a bad connection. I'm just going to go ahead and I'm going to go and just try and tighten up all these connections on the switch. So there was actually two windings that went into this terminal, this number 4 on the switch, and one of the windings had broken off. So I think one thing we need to is we need to strip this And I don't think there's any point in just putting it back on there because the wire's a bit short, and the way that this transformer's flopping around, I think it'll just break it off again. I think that's, you know, part of the problem. So I think we need to strip these off, probably wrap them together, resolder them, and we'll take it from there. Maybe put a little link wire back into that terminal. So I'm going to go and do that. Well, I was just rooting around in the drawers here in the garage looking for a soldering iron, and I've just found this gammy looking old thing, this TCP 24 volt 45 watt, and this was made by Weller, and I think they used to call it a Magnestar iron. The way that it used to maintain temperature is there's a reed switch inside there, and when the reed switch is closed, the resistance wire heats up and the tip gets red hot, and when the reed switch opens, it turns the power off and it cools down, and you can actually click, and you can hear it clicking. But the thing that operates a reed switch is that there's a magnet at the back of the soldering iron tip, and that magnet, as it gets hot, it loses its magnetism, its magnetic strength. So when it's cold, it has a high strength, that turns the switch on. When it gets too hot, it loses its magnetism and it turns the switch off. So it kind of temperature regulates, and when they do it, you can hear them click, because it's not, it's not a fine control, it's either on or off, and you can hear the reed switch clicking open. In fact, it just did it then. I'll just hold it up and maybe you can hear it. There it goes. Well, I don't know what it is, but I think today's obviously a day for breathing in soldering iron fumes. Now I think this joint might be a bit on the big side for this soldering iron because they're not that powerful, so we'll have to see how we get on. It either will or it won't do it. I don't think we're going to do it. Come on, baby. I think we'll leave this wire long because I'll probably come back and I'll probably put a fork crimp on here. I'm just going to solder it and tin it for now and put the connection in, but assuming we can get this thing working a bit better, I will go back and we'll readdress it. Okay, there we go. So it's off at the moment, no light. Position 1, and the light's glowing, not particularly brightly, but it is glowing. Position 2, I think that's a bit brighter. Position 3, brighter still. Position 4, brighter still. Now is that a position 5? I can't quite tell because it's rubbed off. Let's try it. Okay, that's gone off there, so don't know what position 5 is. Is this one of the ones that's going to be a remote control job? No. Alright, so that first position there is something on this remote control. That's very bright, so I think that must be the boost. Tell you what I think we need to do. Let's see if we can get a voltmeter in shot as well. So position 1, 8.5 volts. That seems a bit low, doesn't it? But maybe that would be right if you had a really flat battery. Position 2, 9 volts. Position 3, 9.5. Position 4, 10. So it looks as though it's going up in half steps. Right, and then it goes off there. So is that a fault? Have we got a bad one there? So it looks like this setting here, I think it had a white line that went all the way up there. So that's the timer function. Well, I've just linked the timer out because you know the timer was knackered. So we've got all the settings now apart from setting 5, which doesn't seem to be working. But the voltage does seem a little bit low. I would have thought that a battery charger would be higher than 12 volts. I would have thought we'd be getting at least 13.8, maybe 14 volts out of it. Now I'm afraid I can't test this battery charger at full capacity, but I have got my electronic load here, which is only rated to 300 watts. But I'm prepared to turn it up a bit and let's see what we can kind of get to. So it's got a little power meter on here, so I'm guessing as long as we don't go to 300 we should be okay. At the moment we're drawing 11 amps. Oh, it started making a funny noise. I think that might have been an alarm there. So 15 amps, let's leave it at 15 amps. Well, I'm hoping you can see that our fluke meter there is reading 8.8 volts, 8.89 volts DC. But I want to kind of show you that fluke meters, in fact all digital meters, they kind of lie, because I suspected that there was nothing wrong with the output voltage. In fact, I would have been sure. The problem is ripple voltage. There's no smoothing in this power supply. It's just a rectifier, and that gives problems to the way that the averaging is done with these fluke meters. So with the aid of nothing more complicated than a simple capacitor, I'm going to increase this voltage. So there you go, 12 volts, well 12.8, take the capacitor off, back to 8 volts. So this battery charger is putting out the full rated voltage that it should do. So I think if we do decide to go ahead and rebuild this battery charger, we'll install a capacitor inside it, and we may even replace this broken ammeter here. We might replace that with 2 digital meters. Maybe we can put a digital voltmeter in here and also an ammeter. I don't know, we'll have to give that some thought. But I think for today that will do. We've proven that we've got a good transformer, the switching works, we've repaired the little printed circuit board out. It seems quite capable of outputting 15 amps. If it can output 15 amps, I've got no doubt it can probably output 30. So we've certainly done enough to prove that this is a viable project.